is to really.
Yeah.
So everybody knows that it's being recorded.
Yes, right. So I didn't press the button like that. So I can do it again. Okay. So this content is AI generated. And actually, I asked it AI, can you put together these ideas and show on the picture what is the relationship between the CEO risk taking and the compensation? So I got the picture that the CEO is driving too fast on a bumpy curvy road, right? So that's and what is the bumpy and the curvy road for the corporation? This is a fraud which can happen. The product safety issues, right? If you are pushing too hard engineering team, maybe they were not able to develop the product, and there will be recalls. How many recalls there is in Toyota, Ford, and other corporations? So the organizational misconduct, it's not only fraud. It's also when you have a labor strike, when you treat your employees not well, to save some money, right, and get a higher profits. It's also when you violate environmental laws and other regulations, also to save money, get higher accounting returns, and report that you are doing great and get higher compensation. Because the CEO compensation depends on the financial performance of the firm. That's really reasonable, right? And these are the 4 tests. And I would like to just if you drive too fast, and this guy looks like a CEO, maybe future of management.
Mate, oh, I'm so sorry. I thought there was time.
He's just pulled out. I don't have time to stop.
Well, come on, mate. It was a simple mistake.
I know if I was going a bit slower.
Please. I've got my boy in the back.
I'm going too fast. I'm sorry.
Yes, so the rationale here, so sometimes we probably should not push CEO too hard, because sometimes we should sacrifice some performance in order to develop better products with less recall, with less environmental and other things violation, and actually not putting really hard on our employees, which also kind of can be exhausted. And the question is we have, to which extent, when the CEO is pushing an organization toward this type of risky choices, is it intentional or it is a side effect, right? So we have the perceived understanding in our team that it is more side effect rather than intentional doing the bad things for the organization, right? Because the CEO cannot benefit from product recalls, which will decrease the stock price, and also having the suit for not fulfilling the environmental violation. It is not positively related to performance. It doesn't make sense, right? But pushing organization really forward, it may cost them, right? So, and we're trying to link this phenomena through the lens of the rational choice theory. When the CEO is thinking to making different decision, should we announce the new product, which is maybe undercooked, we should do it now, or we should wait and do other trials. There will be the kind of the judgment in the brain, right? So what is the cost benefit of the decision? And when the benefits outweigh the costs, there should be a decision to take more risk, which also includes the chances of organizational misconduct. Having better performance means you have to take more risk. More risk leads to more mistakes. Bless you. So, and this is basically, that's why we adopt the rational choice theory. We consider that CEOs actually will try to act rationally based on a cost benefits analysis, right? Which is basically means that the decisions will be rational, but the higher performance will require accepting more cases of misconduct. That's why we have the hypothesis. H1A tells us that there should be positive association between the CEO risk-taking and organizational misconduct. Why? Because that this is a side effect of the more choices with a higher uncertainty. However, the agency theory is telling us that the higher CEO compensation developed stronger bonds between the CEO and shareholders, and actually that the paying more CEO will require more vigilant assessment of the decisions, right? So if you really benefit from the successful choices, you will double check everything, right? So we have like a conflicting prediction. That's why we have competing hypotheses. I think like both of them make sense, and because the misconduct is a side effect rather than irrational choice, we may have also negative association between that as well. So what is our context? We use S&P 500 firms. It's a basically largest corporations in the United States. We collected the data about them between 2005 and 2019 to avoid the anomaly with the COVID. And we have we measure the risk taken based on the compensation. And I use the stock option pay characteristic. It's a data and Vega. I can stop more on that. And organizational misconduct is measured as a fraud, the product safety, employee safety, and environmental safety violation. And we have the control variables, about dozens of them on the CEO level, board level, firm level, industry, and year effects. And we utilize the AI-powered coding approach to this. So in our data set is resulted in 43,000 news, which has headline and lead article. And what are alternatives? For me to read these 43,000 articles, I needed to spend 272 days. If I spend 3 minutes per one new, and actually reading 8 hours each day. So basically it's a 1 year full-time job. And when we use automated dictionary coding by the keywords, we have the false positive and false negative. For example, when the name of the organization is in the headline, but actually organization is suing another one rather than being sued, right? So that's like that's why the automated dictionary coding is not very effective. So we tried to use LLM coding, and we were able to utilize prompt engineering and also try to reach high accuracy with fine tuning. And the data was coded during 2 days, not 1 year. Right. So that's like that is a make sense. And this is how the data looks like. So we have the headline about the Xerox Corporation, and we have a lead, and we have the evidence here that there is a lawsuit against Xerox by its investor. So Xerox violated investors' interests. That's why being sued. So this is kind of the fraud. And but still, we need 1% of the headlines to code by the human being. And actually, this human is the Jeff Bailey. It's a senior professor from management department who is specialized in ethic research. So I think he coded very ethically. And probably it took like more than 3 minutes per one headline, right? More than 3 minutes, yeah. So when we have the full professor coding, we need 2 years, right, to do this research, right? So, but it is not enough. We are moving really faster. So we were able to compare different models which have really fancy name. I think like a Michael Overton was helping with this, and I would like to underline my gratitude for that and for the resources provided. Also, the server time was very precious for us as well, right? So, and Michael, can you like maybe say what does it mean? We have the 3 columns, and there is some sort of accuracy right here, like I think it is the average about 85, right? Yeah. The agreement.
So all this does is it's comparing the 3 models across the 420 coded, because we want to run the entire data set on one model, right? Save time. We want the best model. So based on that, precision and recall are various versions of understanding the positive score. So I think precision is a true positive. Well, anyways, it's comparing like true positives versus total positives and true positives versus false positives. One of them, I forget which one. And F-score combines both those as an average. What was interesting about this was that Quinn 32, the smaller of the Quinn models, actually performed better on everything. For those of you who are into this, I don't know why, but it did. So
yeah, so
F1 score good. Yeah. Okay.
So thank you. Yeah. So I think it can be better, right? It should approach 0.9 accuracy. This is actually so the gold standard of the intercoder reliability in management research. This ratio should be consistently above 0.8. So we have couple instances when we have 0.6 and other stuff, right? So again, so that was this results based on a robust prompt engineering, but before fine tuning, right?
Yeah, there was no fine tuning for this rail.
So this is actually what we are willing to do, right, in the future. Yeah, so this is a great citation about how you should develop great prompts and ask AI models to do better job, right? Because this is the second project in my in this fellowship. In the previous, I asked AI to count, and it looks like AI is started getting bored after counting till 12. And actually asking AI to count till like 60 keywords in a text was very challenging. That's why we decided to switch coding approach to binary choices, yes or no, rather than how many misconduct instances you see in the text, right? So that's also resulted the high accuracy rate. In my previous project, accuracy rate was maximum 0.7, which is not acceptable in my field. So then look at this. So I remember when I was a couple years ago, PhD student before my comprehensive exam, and I remember this method seminar with the marketing department chair, and he said, you see, like there is a data, there is a theory, they should work together. I said, Professor, and what if the data doesn't work? We don't see the positive relationship. I mean, he said basically, it's usually something how you collected data or the data. It's not the theory. So when you look at the loading here, so we have 3 factors, right? Fraud, product, employee, and environment. Look at the loading. So this is a principal component analysis. 99 factor loadings. Basically, this means that the subcategories we picked from the Academy of Management annals, they're really distinct different factors of the common phenomenon. So this is amazing. I would say when I saw like a 99 and 4 different factors which loads perfectly, I said we're in the right direction, so I can run regression on this. So this is the whole data set we have. You see, we have a lot of different control variables, and the dependent variables is a firm misconduct as a count of negative, positively coded headlines, you know. And the variables I used here, and there is a smaller correlation matrix. And when you see there is a CEO delta, it's when the CEO is getting more option pay when the stock price goes up. It's logical because the shareholders benefit for a higher stock price. So this is like a direct performance incentive to do more stuff. And there is a Vega. Vega is when only CEO is getting paid from the higher volatility. So I've been curious if actually the Vega will cause more harm because the CEO is motivated only to take more risk, but not increasing the actual performance of the company. And you see like there is a delta negative relationship, some predictors of this, right? So I expected the delta should decrease. So this is a regression. There is a consistently negative effect of the CEO risk-taking or organizational misconduct. So the alternative hypothesis worked, and you see we have like a star and 3 stars. So these are statistically significant results. The regression is has robust standard error and fixed effect controlled, right? And I've been trying to say, so under which conditions actually the paying more will cause that harm. So I found the moderation. The moderation is actually the board total compensation. If you pay CEO and board high, there will be more misconduct. This is the first thing. And also, there is a CEO delta power 2, and it's like a squared, right? This and actually we have the support for the delta, and it also positive. So it means that the relationship, the effect of delta on the misconduct is a U-shape. It is high, decreasing when the delta is low. It is good when it is in the middle, and it is again high. So these results are basically exploratory at this point. It's we are working on refining the theory, but we believe there can be 3 contributions to the different fields. It's a corporate governance, research methods. I think the LLM model selection and the fine-tuning approach brings a lot of value because actually, if you need to quote only 1% of the news, you saving 99% of the researcher time, which is extremely good thing. We also have the contribution of the rational choice theory in the corporate governance context. And we have the to-do list. It's to complete fine-tuning, develop the open source database, publish it via our library so other people can use database, cite our work, right? And publish, right? So that's all. So thank you for your time. I think like I'm 4 minutes before the deadline, so the Jaslam can wrap, right? And the Q&A is in the end. Yeah.
Well, while Jaslam is getting set up, you don't have a question for him?
How concerned are you about watching your corporate donations to the university go down when you publish these results?
Or maybe go up. So, so you see, like that's a great question. It depends on which side of the theory, it's the rational choice or agency. Management theory, agency theory felt that you should pay more and there will be less misconduct. Yeah, but it's like, but there should be some optimum. This is the relationship is a curvilinear.
Yeah.
And searching for that apex point is another research challenge, right? Yeah. Thank you for your question.
Thank you, Alex. Okay, Jaslam, take us away.
Thank you, guys. So I'm Jaslam. So I'm a research scientist with CNR, College of Natural Resource. I'm a statistician, data scientist guy who's working for natural resource to gap between some data science, machine learning application for digital forestry or sustainable forestry, you can say. So when I got an opportunity to work in this generative AI fellowship, so we are always, it was a question how we can get individual tree attributes. Now, suppose say going to the forest and measuring every trees, it's not gonna work. I mean, it works, but it's labyrinthine, time consuming. I mean, it's too costly. So is there any way we can measure individual tree in the forest? So when I ask that, why you really need individual tree measurement? So these are the reasons which we really need individual tree measurement. Like one is precision in forest inventory. Suppose say you exactly know in a plot, in a stand, how many trees you have, what's the diameter of that. You can, the forest manager can have a decision making how many timber you have, how many non-timber you have. That's going to help for him to make a decision, on timber cruising and all stuff. And second one is improved forest health monitoring. So when you have individual tree or health attributes measured, you can pre-forecast. You can forecast if there any pest or disease attack gonna happen, or you can have an advanced precaution measure you can put on that forest or stand. And yep, carbon sequestration estimation, as we are in a area of hot topic of climate change and climate change mitigation stuff going on. So forests play a big role. And so if you have a carbon estimation, if you can have a precise carbon estimation, that will be a great stuff. And another thing is major important wildfire risk assessment. So if you have an idea about how much fuel load or how much moisture content or how much what's the ground structure, then you can make a prediction on what's the probability of wildfire risk and all. And again, enhanced silviculture planning. If if you get the data, then you can understand how much thinning you had to do or how much fertilizer you had to give. So those are the reason why we really need the individual tree attributes. But as again I said, it's not possible to go to every plot, every stand and measure every trees. So what we do is basically based on LiDAR, which is light detecting and reflecting. We make this measurement. So I can just show you.
LiDAR, or light detection and ranging, is a tool used to quickly, accurately, and densely measure 3D features from the world around us. LiDAR sensors can take hundreds of thousands of measurements each second and are represented in the form of a point cloud. The point cloud can be used in various analytical processes to take distance measurements, compute volumes, and model objects in 3 dimensions. LiDAR is an active remote sensing system, meaning that the LiDAR system itself actively generates laser pulses used to take the measurements. These laser pulses are pulses of light that travel from the sensor to the ground and reflect off of things like buildings and tree branches. The reflected signal then returns to the LiDAR sensor where it is recorded and stored as a distance. LiDAR data can be used to estimate tree height, measure power line sag, detect changes in topography from one date to another, and numerous other applications.
Yep. So when you say laser, it's not necessary that you have to fly. You need UAVs. So you can have a terrestrial LiDAR, which you can take a LiDAR, you can walk around. It's a TLS method, or you can have a drone. So there is different way you can collect the data. So as this picture shows, then what we do is we get a forest point cloud out of that from the LiDAR, and from that we can extract individual tree. And what we do is we go to the forest for some plots and we'll take the measurement. It's like, check rows. Then, so with some machine learning methods, we measure species, height, DBH, diameter and all the information. And we make a validation based on our check rows. So that's a step what we are doing now. So we do a LiDAR collection and we extract data from that point cloud.
Phoenix LiDAR Systems is
Yep. So here is one of the example forest plot where we flow a LiDAR flight, and it's a Geiger LiDAR. It's a high intense pole LiDAR, which means we get more points basically. Yep. Basically, these are the trees which you can see. These are good for, so there is 2 things. One is area level modeling. One is individual tree modeling. If you're okay with area level modeling, this is fine. But again, as I said, we are more focused on this research on the individual trees. And so when you go to individual trees, basically what we need is we need to segment. It's a process of dividing the point cloud data into tree crowns and stems for accurate tree identification and analysis. But here again, you can see it's again depend how better your segmentation is depend upon how better your collection is, how better your LiDAR is, sensor is, right? So when we look at all these LiDAR segmentation packages available, it's more for high intense terrestrial LiDAR, which means you have to walk through or you have to do a drone stuff. So which is again not cost effective. And what we had is a UAV, basically a flight past, and we tried to do segmentation based on the existing R packages or Python packages available for TLS, terrestrial LiDAR, and which was not giving any good segments. So this research was a part of, can we make a good, or can we find, or can we generative AI or advanced machine learning can have a good segmentation. So this research turns to, yep. So yeah, when I started asking this question, next day I got an email from Luke. Basically, Luke said that segment anything. That's a meta developed a segment anything, and that's really great for general publication. We can see whether how it's going to work better in our case too. So there are. So after this study, so if you look at the years, this 2024, just 2 months before it is published. So these are the very recent advanced machine learning or deep learning methods available for segmenting trees, like ForAInet and SegmentAnyTree. And the key comparison, basically, when you talk about machine learning methods or tools which we use, so in ForAInet we have we use point group or point net plus plus in the deep learning. But again, as Luke suggested, the SegmentAnyTree, when we look at the details, SegmentAnyTree is a special part of SegmentAnything model, which is exclusively trained for tree detection and tree segmentation. And if you look at the benefit out of ForAInet, so I mean it's almost same, but there are different. It's a packages of multiple statistical or machine learning tools, including clustering, segmenting, training, all stuff. And there are some difference, like as I said, the way of their use techniques they are using into. Here you'll get an exact picture of what I'm talking about. Suppose you get a point cloud here. We do two kind of segmentation. Here you can see is instant segmentation. Instant segmentation means we are looking for each instant, like each trees. Here is a semantic segmentation, where in individual trees we are looking at stems, your branches, stems, and all the stuff. So once you get this information, you can start measuring your high DBH with different methods. So this is the you can say the procedure or workflow of this. Okay, so we also use this one, so you can see the point cloud what we received, and we segmented them using SegmentAnyTree, because the other one ForAInet was just published 2 months before, and we are trying to get this code also. So this segmentation, what you are seeing is from a SegmentAnyTree. It was great. It was doing great jobs. You can see individual trees. They are detecting individual trees. It was fine, but still we had some odd cases. So when you look at, there are some groups. You can see they called these two trees as a single tree, like we see here. And also you can see there was small part which may be part of one of this tree. They called as a separate segment. So can we blindly say that each segment this machine learning or this methods giving is a tree? No, right? So either we need to change your training, go back to your training, do some tuning, add more data from your place area or the area of your interest, or maybe you can have post training corrections. So we were looking at post modeling correction, and one which we did here is, suppose say you have all these trees, we extracted for each segment, we extracted the attributes of that point cloud, like, what is the number of points in the, what's the height of that, what's the area, volume, all those variables we extracted as a tabular form. And we used an H2O AutoML. And why we used H2O AutoML is, again, say auto. You don't have to do any data processing. You do not have to work with your multiple models. It will do everything, right? You just give the data. It's do your data processing, model generation, ensampling, and all the stuff. Yeah. So what I did is I just extracted all this information and gave to H2O AutoML. And you can see that it's trained multiple models like deep learning, GBM, GLM, or random forest and all. And it's gave me a model which is that out of the leaderboard, the champion model was an H2O gradient boosting method, GBM model. And you can see the confusion metrics, and it was pretty good. So moving forward, what's our plan is, after getting a segmentation, we will pass those tables to our this GBM model, and we'll see whether the segment is good or not. So if it says it's good, fine. So we only focus on those error part. We only want to go to that. We want to go to those errors and might want to make correction visually going to that. So this is the first part. And second part, moving forward. So when I showed a presentation in our meeting, and Michael suggested, instead of table, can we take the images and train a model? Of course, there was a scalability issue. Yeah, we talked about that. But that discussion taken to another discussion with Luke, basically. So he said that, so earlier I showed you the SegmentAnyTree. The ForAInet has the ability to convert them to 3 parts. Like said, this is the segment. They can convert to tree, stem, and some branches, right? You can see here. So here it's clear. So when you go to a pre-segmentic, you can see there is tree stem clearly. So can we use this pre-segmentic information directly instead of creating these tables and all? Can we train a model? Visual, we can have a code visual methods of training a model. So this is what we are focusing now. And even though this fellowship is going to end, we hope to work with Luke and Michael and try to accomplish this too. So that's pretty much I have. Yep.
Yeah.
Thank you so much.
Well, open up for questions for our two presenters today. Yeah, let's go ahead and ask. Go ahead, Barry. Kick us off.
Okay, so constraints, like I know that you're sort of just getting to the point where you're like, okay, can we incorporate the vision model and that kind of stuff? Computational resources and constraints. Like, do you have a sense yet of what will be required, whether we're geared up enough to do it here, or if we're missing hardware?
Again, thanks for this IIDS fellowship. We used that by 2000 funding, and we ordered a super computer with a GPU. And so the normal CPU, even if it is 60 GB or 32 or 64 GB, it's very tough to, with CPU processing was very tough. And I used to process some of this segmentation using our high performance clusters, and sometimes use Falcon too, but Falcon's got some issues. So mostly I used to IIDS high performance clusters to do, but still, we hope to have a GPU with Windows based. We need Windows. It's not on Linux based, because the reason we need to see this stuff. So we are going to have a GPU within the Windows OS system.
So you need a local GPU.
Exactly.
Work with the software that you're used to working with and potentially train.
That could be the best option. Otherwise, we have to run somewhere and take all this, then visual. Yeah.
What did you order?
It's a GPU. I mean, I don't have exact information.
Some big GPU.
It's a good GPU. Yeah, it's almost it's almost $5,500.
Oh yeah. Oh, we're spending $20,000 for GPU and other stuff. So. Yeah, and I just have the same question for Alex, right? Like, how do you feel? Are you sort of finding any limits in terms of infrastructure and compute.
So yes, I found the limits with my previous research project because it has 22 million observations, and when I calculated how much time I will need to code that app description, it took a couple years.
I thought Jeff was doing
So the Jeff can do like that.
400.
Yeah, that's right.
it.
Yeah, and the previous estimation was 1 minute per per app description with also kind of like a one-page text about something. So I feel that the research in the social sciences will be more and more required using the AI to do most of the reading, when the human being will just use just to double check if we are on the same page to coding the different data. And this approach for the coding, I think, is applicable for any text description. I truly believe there can be extracted psychological traits from the
So I agree with you on that part, but what I'm wondering is, when does our on-premises infrastructure that Michael was using, like, fail because of the size of the data set? Do you have a sense of that? Like, or Michael, maybe you do, or?
Yeah,
Pretty soon. I mean, here's the thing, it could quadruple and it'd be okay. Like, one of the things that I want to do with the coding that what weren't able to do, partially because of time, partially because it would just take forever. Each of the true or false questions, the best practice is to separate those into a separate call. I put them all into one call. And when I tested with the 420 coded, we didn't really see much of a difference. So automatically, what I want to do is something that would quadruple the compute time to get it done. And then if you're talking about if you want to compute true test, retest, or social science validity and reliability tests, you need to run it probably all again. And then if you want to do some other social sciencey tests, running it with the top performing models if they are doing it bad, so that you have 40,000 calls, but across 3-4 different models.
Let me rephrase the question, then I'll be quiet. So with Jaslam, it sounds like you're doing a local thing, so that's okay. But for this kind of stuff, what I'm asking is, how much money do I need to spend on GPU infrastructure like over the next year to meet the wave of demand?
I don't really know the cost of the hardware, but I would think that like giving us API and a really user-friendly manual how to, for example, I use the SAS. And if it will give me API to do the SAS, I will be frequently using it because it's like, and I will be staying alive. Because actually, I spent yesterday for doing what?
I don't know.
The date I got the data set in the morning, and it is 44,000, and I needed to delete 1,000. That 1,000 was in a different language, and I needed, this is the panel data, I need to put the count of the headlines in a year. And there was a different date format, which was really difficult to convert. So I parsed the date into the year, and I thought, come on, can I ask AI just to extract the date in that cell? And you see, it having this tool on a request, and that can be really simple model. That could save the whole day of my work. So I think it is not rather than hardware, which can be really somewhere in a cloud, not necessarily here, but actually providing us access point with some manual readable, which we can use, and maybe providing some consultation on that will really boost our work. And many other scholars on different colleges will use more. And you can scale up into somewhere in the cloud, not necessarily separately here, but actually helping us doing this is more important. Right? Because without Marco, we were not able to achieve any results.
What I'm hearing is you value access to the experts and then maybe the documentation that helps you really get in and use this stuff over how many GPUs.
I'm fine with the having black box. I'm fine with the black box. Just I need focal point.
That answers my question. What do you want to say?
Well, I'm gonna ask a related question because you said you use SaaS, and so I know at least in our department, like more and more people are actually starting to use R now, because it's free and you can expect to continue using it when you're teaching grad students or not. Is that this true in business as well? Because that might be a way of answering the question as well, which is like
So,
training on some basic programming in R that interfaces with
So,
the models.
in my research, so the tables you saw in the end, it was in a start.
Yeah.
Starter was purchased by my department.
Yeah.
The data was merged, ForAInet, and put in the panel with the SAS. SAS was purchased by my department. Yes, most of that stuff can be done in R, and I have skills in R. The point is, using R, it's like driving car with a shift-fixed transmission. And I have it automated. And using the Python, it's using like a car with 1 gear transmission, but you can go everywhere, and it's like a car helicopter. So the point is, what is more valuable, the license or my time?
Yeah.
I think my time is more valuable than the $200 license for a startup. And why I use the starter, because the starter export nice tables in that, and the SaaS doesn't have it. So we are trying to say, and actually what I'm trying to say, it's not that, and actually the statistical algorithms are the same in each statistical package. They're all the same. Just that people spend a different amount of time for a human interface, which actually creates the huge value. So not only engineers and data coders can use it, but the people with basic statistical skills as well. And that's why the people purchase SPSS. It is even more user friendly, and it is good for undergraduates. Yeah, so
What I'm hearing from both of you is, if I had, $200,000 to spend, and I could spend it on cloning Luke or more hardware, you both vote for cloning Luke.
cloning, of course.
And the wooden one will want more hardware.
Yeah.
Would be like, hey, where's any more?
So you need double that.
As a manager professor, I would suggest start the PhD program so you can hire like a low-paid research assistant, PhD student, so he can redistribute his job.
Okay, I think if I pay Luke too much, what I've learned is he'll be motivated to take shortcuts and.
Yeah. Yeah, so then make more loops. You see, it's not hard, make more of them.
Always trying.
No, I think that what it said was if you paid his governing board too much.
Oh, that's me.
Recording.
I don't know.
Yeah, it's not.